In this video, we will practice finding the relative extrema and points of inflection of polynomial functions. This is AP Precalculus topic 1.4. The previous video is where I introduced all of these topics, so if you haven't watched the previous video, you should watch that one first. I will try to put a link in the upper right hand corner, or you can find the link in the description. Use your graphing calculator to graph each of the following functions. Then use the calculator to answer the following questions. Time to break out your TI-84. Hit the y equals button and type in the first function as y1. So type it in like I just did. Before we start graphing, we need to adjust the window. So let's look back at the assignment. It says where x is between -3 and +3. So that tells us the x min and x max. So hit that window button and let x min be -3 because that was the lower bound, and let x max be +3. I don't know what the y values are needing to be like, so I usually start off with a range of -10 to +10, and then I make adjustments from there. So I'm going to start off like that. Hit graph. Let's see what we've got. Okay, pretty good. It looks like I'm missing a relative min over here on the right hand side, so I'm going to drop the minimum y value down somewhat. So I'm going to go back to the window. I'm going to turn y min to -20. And that should do it. Alright, now we are ready to go. So it says we need to find where f has a relative min. Alright, we need to find that x value. So we see the relative min is going to be over here. It looks like it's somewhere near +1, but we need to be precise to 3 decimal places. So hit second trace, and for a relative min we use option 3. When it says left bound, use your arrow keys to move the pointer to somewhere to the left of where you know the relative min to be, and hit enter. And then it's going to ask you for a right bound. Alright, use your arrow keys to move your pointer somewhere to the right of that relative min and hit enter. Then move your pointer right to about where it looks like the relative min is and hit enter. And there it is. We have a relative min at x equals 1.013. Be careful, the graph looks something like this, but because of the or equal to symbols here, this is the closed interval from -3 to +3. In other words, these are like closed circles, and therefore the endpoint can be a relative min. So we have another relative min right here. Of course, that is going to be at the left boundary of the domain. So we know that's going to be at x equals -3. Part C says, wait, I didn't mean to put that there. So we have a relative min at 1.013 and -3. And then we need to find the x-coordinate of the relative maximum. So back to the calculator. And we see a relative max right about there. Let's do second trace max, so we'll choose option 4. It's going to say left bound, so use your arrow keys to move somewhere to the left of where you know the relative max to be and hit enter. Now it says right bound, so use your arrow keys to move somewhere to the right of the relative max and hit enter. And then use your arrow keys to move very close to the relative max and hit enter. And there it is, x equals 1.013, -1.013. comma. And again, the endpoint is going to be another relative max. So we have another one at x equals 3. Now, let's move on to part C. F changes from increasing to decreasing at x equals what? It says increasing to decreasing. So when we talk about increasing to decreasing, that's going to be a relative max. Okay? Increasing and then decreasing. That's a relative max. So that's going to be the one where we said x equals negative 1.013. Okay, it's this one that we found. Go ahead and type this function g in as y1 on your calculator, and go ahead and set the window. X min should be -2, x max should be +2. I've typed it in, and now I'm going to hit that window button and change my x min to -2 and my x max to +2. I'm going to leave the y min and y max the same as they were on the last problem until I see that I need to change them. So let's hit graph and see what we've got. Okay, I feel like we're seeing everything we need to see. G of x is doing one of these deals, and we are being asked to find the location of the relative min. So that's going to be here in the middle, and also we have the two endpoints because this is again a closed interval, okay, with endpoints from -2 to +2, just like if we had brackets like this. So we might as well go ahead and say x equals -2 right now, and we're going to have another one at x equals +2. We just need to find the one that's in the middle. So back to the calculator, and it looks like it's probably at 0 or close to 0. Anyway, let's not guess. Second trace minimum, that's option 3. Left bound, you say. So let's be somewhere to the left and hit enter. Now it asks for right bound. Slide over somewhere to the right, a little bit further, and hit enter. And then now it says guess, so I'm going to move back to the middle and hit enter. Okay, so you're going to run into this sometimes. This E with a -7, so let's see, so it says -9.197. Here's what's happening. This is -9.197, and that E means, that E with a 7 means times 10 to the -7th. Okay, it's an E with a -7, so that's times 10 to the -7th power. So that would be like moving this decimal place to the left 7 times. So this is really -0.0000001, 2, 3, 4, 5, 6, and then 9. Why is there a heart there? 9, 1, 9. Anyway, the point is this is a really, really, really small number. Certainly to the nearest 3 decimal places, this is actually 0. So we're going to just put 0 right here. Now it's time to find the absolute maximum value of G. Okay, so I think the left side, I don't know, I could be a little bit blind, but to me it looks like the left side is a little bit higher than the right side. I'm going to have to check them both just to be 100% sure. So let's go ahead and hit second trace. And we're going to do maximum, so option 4. So I'm going to slide to the left of that first max, and I'm going to hit enter. Right bound, you say? Fine, I'm going to be over here to the right, hit enter. And then for the guess, I'll be here in the middle. Okay, so this is the location, but y equals 6.784 is the maximum. Okay, so the absolute maximum value of g is, what did I say, 6.784 at x equals negative 1.130 if you round up, negative 1.130. Okay, I will erase this if it turns out to be wrong. So let's check the other side and see if this hill is at the same height or maybe higher. So back to the calculator, let's just run it again. Second trace 4 for max, but this time I'm going to slide over to the right hill. Okay, this is good enough for a left bound, so I'm going to hit enter on that. Okay, now I feel like I'm clearly past. I'll go just a little further. Okay, boom, right bound. Now I'm going to move somewhere close to where I think it is, and I'm going to hit enter again. So it should be somewhere in there, and kabam, 6.784. All right, that's exactly what we had last time. Because we have the same height, which is the maximum value at two different places, we have to list both x values though. So this one is at positive 1.130. Okay, so I'm seeing some symmetry here. G changes from decreasing to increasing at x equals what? So decreasing to increasing means we are talking about a relative min. Okay, so that's going to be the one that we found that was right here, and that was at 0, so x equals 0. Go ahead and type this one into your calculator. Adjust the window so that x min is -1 and x max is +1. Let me teach you some extra stuff even before we type it in. When the degree is odd, for a polynomial, you're going to have end behavior that is falling on one side and rising on one side. If you have a positive leading coefficient, like this, okay, I'm just going to write this as sort of a model, then the end behavior will be like this. If it is a negative leading coefficient like this, then it's going to flip the other way, okay, and it will be down on the right. Okay, so if it's positive in the front, it's up on the right. If it's negative in the front, it's down on the right. So looking at this polynomial, before I even look at the calculator, I already know that the end behavior is going to be like this. So here I've typed it in, and I have adjusted my x min and x max to -1 and +1. Let's hit graph and see what's going on. And the end behavior matches what we predicted, so I feel like we're seeing what we need to see. So they're asking us to first find the location of the relative min. Okay, so we're looking for the one that's around in this area. Okay, so that's going to be somewhere around in here. So let's do second trace min, option 3. For left bound, I need to move anywhere where I know will be to the left of the min. And for right bound, I need to definitely be to the right of the min. Okay, so I'm going to keep going until I know it's going kind of up a tiny bit. Okay, so I know the min will be in here somewhere. So I'm going to move my pointer back to the middle for the guess. Okay, so here it is. X equals -0.164. Okay, x equals negative 0.164. Don't forget the endpoint does count as a relative min, but we know that is at x equals 1. Part B, where does h have a relative max? So we're looking for this guy. Okay, so it's going to be somewhere over here. Second trace max. All right, left bound. You know what? This is just fine for the left bound. I'm just going to hit enter. And now I'm going to move for the right bound. I just need to be somewhere decisively to the right. Okay, I think I passed it. And then for the guess, I'm going to move over to about where I think it is and hit enter. Okay, 0.492. Okay, I'm going to leave a little space here, 0.492, because we also have a relative max at this endpoint, which we know to be at negative 1. So negative 1 and 0.492. Part C, h changes from decreasing to increasing at x equals what? So decreasing to increasing is this relative min right here, and that's the one we found that was at negative 0.164. Number 4, go ahead and type function k into the calculator as y1 and set your x min to 0 and your x max to 5. By the way, even degree. When you have an even degree polynomial, the end behavior will be the same on both sides. So this type of deal. And this is what it looks like when you have a positive leading coefficient. Both ends are going to be pointing up. Of course, if we had a negative leading coefficient, both ends would be facing down, more like this. All right, but we have a positive, so we're expecting a graph that looks something like this. Because of the closed interval, I'm going to go ahead and model it like this. I've got it all typed in, and my window is set from 0 to 5. So let's take a look. Okay, I feel like I need to see more than this. So I'm going to increase my y max and decrease my y min. Okay, so let's go. I'm going to let my y min be negative 50 and my y max be positive 50. Let's see what we've got from that. Okay, I feel like I need to see even more over here. I'm going to keep going until I see it go all the way to the end. So I'm going to change that y max again. Let's go for 100. Sometimes you got to play around with it a little bit. Okay, you know what? I may just never get there. Okay, I'm going to go to 200. If this doesn't work, I'm going to keep playing with it off camera. Because I really would like to see it go all the way to the end. I'm going to try a few more values. I'm going to keep doubling until I see it get to the end. Okay, this is at a y max of 800. So what are we being asked to find? We need to find the absolute minimum value and the absolute max. The absolute min is going to be somewhere right in this area. So here we go again. Second trace. Option 3. Left bound. Get on over to the left. Hit enter. Right bound. Be somewhere definitely to the right. And hit enter. Guess. Move to where you think it is. and hit enter. So we have an absolute minimum value of negative 47.635. Negative 47.635. At x equals 2.536. Okay, that is the absolute minimum and its location. The absolute maximum is going to be this point off to the side, right? It's at the right extreme of the interval. So we know where it is because the interval goes from 0 to 5. So we know this absolute max is going to be at x equals 5. So it's just a matter of what is the value of this function at x equals 5. All right, an easy way to find that from the graph is to do second trace value. And you can just type in the x value that you want. So I'm going to type in 5, and I see that the y value is 530.44. Okay, so 530.440. That is the absolute max at x equals 5. New directions. The graph of h of x is shown below on the interval from -1 to 7, closed interval. Find the open intervals where the rate of change of h of x has the following properties. You should memorize this chart showing the graphical relationships between f, the rate of change, and the rate of change of the rate of change. On your next test or quiz, I would write this chart on a piece of scratch paper and use it for the whole assessment. Number 5, we are looking for where the rate of change of h of x is positive and decreasing. Well, the rate of change is going to be positive wherever f of x is increasing. And the rate of change is going to be decreasing wherever the function, well, h of x, is concave down. So we're looking for where h of x is concave down and increasing. Let's start with concave down. So h of x is concave down roughly from here to about here. So what part of that is also increasing? Well, it's increasing for this first part from here until the relative max. So the open interval, meaning we're going to use parentheses, is going to go from -1 to 1. All right, problem number 6. We want the rate of change of h to be negative and decreasing. Well, the rate of change will be negative when h of x is decreasing, and the rate of change will be decreasing when h of x is concave down. So, where's h of x concave down and decreasing? Well, we already discussed that h of x is concave down vaguely. I'm going to say from here to here. I'm going to go ahead and call it. Let's say that the point of inflection is about, let's call it at x equals 2. I'm estimating a bit, but I feel like that's a good guess. So there's your concave down. So it will also be decreasing in this little interval right here, from the relative max to the point of inflection. So that is the interval from 1 to 2. Number 7, on what interval is the rate of change of h of x positive and increasing? Well, the rate of change will be positive when h of x is increasing. And the rate of change will be increasing wherever h of x is concave up. So we're looking for where h of x is concave up and increasing. H of x is concave up on this interval, and from that we can see that it will also be increasing from the relative min until the end. So that is from 4 to 7. Number 8. Where is the rate of change of h of x negative and decreasing? Well, the rate of change will be negative wherever h of x is decreasing, and the rate of change will be increasing wherever h of x is concave up. So, where is h of x concave up and decreasing? H of x is concave up on this interval, and then it is also decreasing on this interval. So that's from 2 to 4. Number 9. Consider the graph of g of x shown above. For each of the following intervals, determine if the rate of change of g of x is positive and increasing, positive and decreasing, negative and increasing, or negative and decreasing. Let's start with the interval from 3 to 4. So that's right here. Okay? Now, on this interval, is g of x increasing or decreasing? I can see that g of x is decreasing on this interval. It's simply going downhill. And because g of x is decreasing, that tells me that the rate of change is negative. How about the concavity of g of x? Well, this is part of an interval where g of x is concave up. Okay, so since g of x is concave up, that means the rate of change is increasing. So this is an interval where the rate of change is negative and increasing. How about the interval from 1 to 2? The interval from 1 to 2 is right here. We can see that g of x is increasing, so that makes the rate of change positive. We can also tell that this is a portion of the graph where g of x is concave down, which means that the rate of change will be decreasing. So this is an interval where the rate of change is positive and decreasing. Let's consider the interval from 8 to 9. From 8 to 9, g of x is decreasing. So that tells me that the rate of change is negative. On this interval, g of x is also concave down. See the umbrella shape happening throughout this interval? So concave down, therefore the rate of change is decreasing. So on the interval from 8 to 9, g of x is negative and decreasing. Finally, let's look at the interval from -1 to +1. So that's going to be from here to here. Clearly, g of x is increasing, which means the rate of change is positive. And this green portion of the graph is concave up. Therefore, the rate of change will be increasing. So this is a part of the graph where the rate of change is positive and increasing. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.